And good morning, everybody. Dan Thomas here from News 4 for Weather School for Kids. One of my favorite parts of the week. This is so fun because we get to talk about weather. We get to do so many fun experiments. We've got a bunch lined up today, one of which actually was given to me by my daughter. So we're going to end the session with that. And we'll talk about the main topics today are hurricanes. Now, I know Melanie Layden covered hurricanes a few weeks ago on this Weather School for Kids, but because weather is only so broad, and we do this every single day, we'll have to do a little repetition. But my view of it is going to be a little different because we'll have some experiments too, and we'll talk about radar. So we talk so much about radar here in Middle Tennessee. We have our own live radar called 4-1 real-time radar. And so we'll address how that works and how radar works in general and show some cool pictures. Thank you so much for spending part of your morning on this with us. We do this Monday through Friday at 11 o'clock in the morning, and it's always, again, so fun. It's great for the kids to get a little science education as they continue to homeschool, and it's great for the parents to have some fun. If you have some questions, feel free to just reach out and ask, and we will take those as we go. Now, you could hear behind me just a moment ago, and can everybody hear me okay? I hope so. Just let me know if you can't. I was cooking something. We are going to first start our session today about talking about why the air rises to help make us have clouds. And so typically it has to do with something called density. You ever hear of density? Density is essentially a property of something that has to deal with how compact it is for a certain size. And so the interesting thing about water is that its density will change based on its temperature. And so I've got, hot stuff there, hot water. And so what I'll do is, it's pretty hot. What I'm going to do is pour that into here. This is an experiment you could do at home with your parents' help if you want. And so we're going to show how warm air rises. Now I'm using water. The thing about the atmosphere is that the atmosphere is made of air, and air works just the same as water. They're both what we call fluids. And so the properties work just the same. In fact, in college, I went to Penn State, and I took an entire class on fluids, and it really focused on water, but my application was air because I deal with air in the atmosphere. So let's add some red. Now we're going to add, typically a little food coloring goes a long way, but I want this to be super duper red, and I'm going to try not to make a mess on the counter. And I really want that to be a little more red, so we'll put another drop or two, and hopefully my wife doesn't get mad at me the next time she goes to the cabinet and looks for red food coloring, because a lot of it is in that container. So let's mix it up, make sure it's nice and reddish orange. Again, I had boiled this, or close to boiled it, so it's pretty hot, so I don't really want to touch it anymore. I'll move this out of the way. I've got some saran wrap. Let's just get this out of here. And so put a little bit of saran wrap on the edge. Now, I did this last night in sort of rehearsal, and I learned something, that if you do this at home, it's going to be best to cut away the excess at the edges. But I didn't have a rubber band, believe it or not. In all our office supplies upstairs, I couldn't find a rubber band, so this is one of my daughter's or wife's hair ties. And so I'm going to get some scissors and just quickly trim away the excess so that this does not impact. I think I hear my son. I think I hear him running around upstairs, and I think he's going to join us. Sadie is right by our side, and she is going to help us with a final experiment. Yeah. Okay, so just getting this extra stuff out of the way. And now we're going to take this container, which has hot water, which is less dense than cold water, and put it in this, which has cold water. And we'll see what happens. We set it down to the bottom, and if my seal is good on that hair tie, nothing will happen to start. But now I get a sharp knife, and now I poke holes in here, and we can see how, just like in the atmosphere, warm air is less dense than cold air. So in this, warm water is less dense than cold water, and therefore it must rise. And that helps us have clouds, that helps lead to hurricanes, that helps the science of meteorology happen because of changes and density. Let's get it going a little more here. See if we can really get that to rise. Look at that. That's amazing, huh? You can do this at home. Again, just a little hot water and a big thing of cool water, actually cold. I actually had some ice in here before, and you can see the rising currents of air. Isn't that neat? So now that we know that that is just a rising current of air, we can do some cool things. We've done some interesting things before with air pressure. Again, air pressure is very important. This is so easy to do at home. Follow me to the sink just for a minute. Thank you, Sadie, so much. Follow me to the sink just for a minute. And so, this is just a little bottle of water that I drank before. I got it at Costco. All you do is turn on the hot water. Now, again, mom or dad will want to be nearby, but hopefully your water heater is not so cranked up high that you're going to scald yourself, and I want this to get cooking. And so, again, the bottle looks normal. It is normal. There's nothing too fancy about it. But I'm going to put some hot water in here. And fill it up. Fill it all the way to the top and get that warm air in there, warm water in there. Now I'm going to dump it out and I'm going to cover it up. Now, because this was hot, there's a lot of water vapor in there, but listen and watch. And as some of that water vapor cools and condenses on the side of the bottle, you can hear it cracking as the air pressure in the room is pushing in. So the air pressure in this bottle is going down as it cools. Let's listen for a little. Ooh, that was a good one. And so as it cools, it condenses, and the pressure goes down inside, and the pressure in the room is too strong, and it starts to crush that. Now we're going to do something interesting with this. Let's kick it up a notch. Let's take this slightly dented bottle and put it in the freezer, and we'll check back. If somebody can remind me in 5 minutes, we'll check back. It's still popping here, and we'll see how squished it is. With this one, I love clouds so much. Clouds are a big part of hurricanes. Let's make a cloud. And so we get our hot water going again. You can do this at home. This is really awesome. And so we just, we want to warm up the container first, and then we get it going. And that's all the water we need. We turn it off so we're not wasting water. And so I've warmed the container. As all this water pours out, we're leaving a lot of water vapor in there, and I cover it up. I cover it up good. Now, just like before, this is going to do a little popping. Maybe we'll let it do its thing for about 30 seconds. And then we're going to make a really cool cloud. And we're going to do that by, you need somebody strong, so hopefully you're strong. If not, maybe mom or dad are nearby. You take this thing, and again, the cap's on tight, no magic here, and twist it tight. And so you twist it about halfway and try to really crank up the air pressure in this bottle as much as you can. Just like that. And then you open it suddenly and watch how we'll have a cloud form. Did you see that? You see that? You can do that at home. That's a simple cloud, all because of changes in density and changes of pressure in a little water bottle that we sometimes drink from and then just recycle. So pretty cool. The next thing we're going to do is transition more to hurricanes. So that talks about the warm air rising, and that one talked about the pressure being important. Let's make a hurricane. You can do this from home, and this is pretty awesome. What do you want me to do? Yeah, I'm going to stir it. Yeah, thank you. And so let me get my little notebook out of the way. I've got so much going on today. I've got a little notebook so I don't forget to do something cool. I don't want to cheat you guys today. So this is just a glass bowl, obviously, and I filled it halfway. I filled it halfway because yesterday I soaked the counter, so I had to smarten myself and do it a little better. I put it on some white paper because that will cause the contrast of the hurricane to work real well. So I get it going really good. Get rid of my spoon, and I put in, as opposed to a bunch of drops, I just put in 1 or 2 drops, and I watch my hurricane form. This essentially is what a hurricane looks like from outer space on a satellite review. So satellite detects a whole lot of things and measures a whole lot of things, but really it focuses on clouds. That's where we use it most in everyday meteorology. Can you see that spin? And can you see how on the outer edges, notice on the outer edges it's spinning more slowly than close to the middle. And that's really what happens with hurricanes themselves. Around the center, we call that the eye, we get the worst damage right around that center. And so that's where that center goes. That's what we really care about. But the outer edges, the winds are typically a lot less significant. And so if a hurricane's coming near the coast, the areas that have greatest concern are where that center is going to be. Isn't that cool? It's a little hurricane in a bowl. You can do that yourself. I chose blue because I thought blue was just sort of neat with that water. Let's get my yo-yo. This is actually not mine. This is my daughter's or my son's. Who knows? We got this at the Dixie Stampede. Have you been to Dolly Parton's Dixie Stampede? That thing is awesome. I mean, like we went twice. It was so good. And it's just a great dinner show, so well produced. You can tell Dolly's got her hands all over the whole thing because it's just well done. Anyway, that's my Dolly Parton Dixie Stampede story over in Gatlinburg. But I'm going to use the yo-yo to show you about hurricane winds. Now, hopefully, this thing doesn't break. Why don't you move so I don't knock you out, please? So this demonstration shows that a hurricane, let's not hit the ceiling, this is sort of like a hurricane. It's spinning, and out toward the edges, the winds, you could see they're represented by the yo-yo spinning around. They're sort of moving along pretty good, but with the same momentum as the wind gets closer to the center, watch the yellow ball, watch that yo-yo, and as I wrap it up on my fingers, it will get faster. It will accelerate as that momentum is conserved. Watch this. Watch the yo-yo and how it accelerates. Do you see that toward the very end? And it shows as that energy is drawn inward, it has to speed up. The same with a tornado. Closer to that center of the tornado, the winds will be stronger. So sort of a neat thing you can use to demonstrate. Just don't knock somebody out with this as you spin it around. Let's talk about hurricanes and names of hurricanes. These are sort of cool. This is for 2020. So hurricane season, what is today's date? Sadie, do you know? No. Read Mommy's watch. 28th. Oh, it's my parents' anniversary today. Happy anniversary, Mom and Dad, if you're watching right now. Hurricane season starts in just over a month, and so every year we have a list of hurricane names. And this is for the Atlantic Basin. We call it the Atlantic Basin because it's not just the Atlantic. It's also the Caribbean Sea. It's also the Gulf of Mexico. They use all these names in the 2020 hurricane season. Then we have a new set of names that's over in the Pacific. And the thing about these names is that the name list changes every year but gets recycled. You know what recycle means? That means reused every 6 years. So we had this list in 2014 and we'll have it again in 2026. But let's go down the list. This is interesting. If you know the alphabet, little kids watching right now, you know that there's probably 26 letters in the alphabet. We have 21 names on here, all in alphabetical order. But what we've done is we've skipped Q, we've skipped U, and we've skipped X, Y, and Z. Why that was chosen, I don't know, but probably because names are less frequent there. But we've got some neat ones. We've got Hurricane Dolly. We just referenced Dolly Parton. That's sort of cool. It could be a tropical storm this year, but my guess is we'll get to Dolly. And so we start at the beginning. We go down to the first name storm will be Arthur. And then down here we've got a tropical storm or Hurricane Hannah. Maybe there's a Hannah watching right now. We probably have a Kyle watching. We have Laura Bannon on the forewarned storm team. She could be a hurricane this year. Wouldn't that be cool? And not so cool if she hits the coast, though. Hurricane Nana. Any Nanas watching? Just about everybody has a Nana, so that could be interesting. Nana actually formed in 1990, then again, I think in 2008, and didn't cause much in the way of problems. So hopefully Nana's a good one this year, and we don't have to worry too much about her. And then this is my general manager. Ooh, she's probably on a conference call right now, Renee. So it could be a Hurricane Renee. Hopefully not, though, because that would be the 17th named storm. Pretty cool, huh? All right, let's talk about radar. So we'll change gears. We use radar to detect where wet weather's happening, where there's some bad weather, where we've got the rain with a hurricane, where we've got tornadoes. A couple pictures I want to show you about the radar just for a moment. As we step away from the computer, we come on back. And oopsie. This is a picture of a radar. So a radar essentially is a big thing, a big dish that sits up on a big tower. And so you can see the big tower. You can't see the dish because it's got a protective covering that sort of looks like a golf ball. And within there is the dish. Now it's protected because we don't want things to bother it like hail or terrible weather. So it's got a little dome around it. We call it a radome. But this is a radar, and that dish inside spins and constantly sends out energy. Now, I was talking to my mother yesterday, and we were talking about ideas for Facebook Live, and she said, what do all those colors mean? Let's demonstrate what the colors mean, because the radar, that dish, is constantly sending out energy at the speed of light, and then it receives energy that it is sent back from whatever it sends it out to. So if a radar sends out some energy and it hits something really hard, a lot of that energy is going to bounce back toward the radar. But if it sends out energy and it hits something sort of flimsy, not as much energy is going to come back. So to demonstrate that, let's pretend that the closet door here is hail. It's pretty hard. It's made of ice. Hail is made of ice. It falls in thunderstorms. And then this, my son's jacket, will represent rain. And so rain is not really hard. It's just like water, liquid water, and that's not hard. But it's something out there to bounce back. So we've got Nerf balls that I had trouble finding, but we found these a couple years ago. Oh, Sadie wants her jacket on there? Okay, you want to swap out with Hudson. Okay. All right, so this is Sadie's jacket. So we'll use Sadie's jacket for this. So the radar sends out a beam of energy, and it hits, watch this, it hits the hail, and it bounces back nicely. But when it sends it out toward rain, it sort of dribbles down. So you get less of a return back toward the radar for things that are less solid, if you will. And so the radar, the computer itself, that's attached to this radar makes a picture, so you can see it sends out the energy, it bounces back, and some of that energy comes back to the radar. And then this is an example of a picture that we can get. Now, this is not live. It says live Doppler. This is, obviously, you can see, hey, Hudson, you can see from the time. This is 6:39 about 2 years ago, some night in March. So this is old school. This is old news. But this is a storm that I pulled up this morning, and it shows down along the Tennessee and Alabama line. The brighter colors, the hotter colors always show where we've got the worst weather. And so here's a thunderstorm, and this is actually a thunderstorm producing a tornado in northern Alabama. So this is the Tennessee-Alabama line. North of here is Tennessee, and south of here is Alabama. And there's a tornado right about here. But this is a big part of the thunderstorm that tornado is part of. And so up and through here, we've got a lot of rain and hail. And then here's that tornado back and through here. So that's one radar picture that we can see. And then this shows where the hail is. Let's go back. This is the same time. You can see the heart of that pink. So the brighter, hotter colors indicate where the radar got the most energy back. We've got a lot of hail, or we had a lot of hail 2 years ago when the storm hit. And then rotation, we can see with our radars how the wind is moving as well. We call this rotation detector on News 4. This is our new, look at our new graphics here. So we are going to come back to that in a minute. I think I'm going to where Hudson is right now. Hudson, you're actually tinkering with part of my experiment. Thank you. Let's take a look at this. Hudson found this stuff. And so this is to show how one other part of News 4's radar system gives us great information. So the radar sends out a beam of energy, as we talked about, and some of that bounces back. But the radar is so smart, it can determine what's out there and whether the things look similar. So I just went to the playroom 5 minutes before we started this, and there's a couple of stamps from the kids. There's a little Lego thing. Here's a little, I don't know what this thing is, probably from Legos. Is yours? Okay. It's a net, yeah. So, but they're all similar in size and shape. Comparatively, look at this. If the radar ever sent out a signal and it bounced off all these different things, this is an eraser for a dry board, a piece of, a little booklet for my microphone, cord from a microphone, and a drumstick. The radar would know that these things here are different sizes and shapes versus these things, which are similar sizes and shapes. That's important because when the radar sends out a beam of energy and it's just seeing rain or some rain and some hail, it can tell us that, or it can tell us when maybe we've got a tornado. We've got things of all different size and shapes. So come back to this picture here and take a look. Take a look. This is what we call at News 4 on a 4-1 real-time radar debris detector. And so the radar uses the technology I just talked about over here with those toys to paint where in the storm things look different from one another. A big piece of this, a long piece of that, a tiny piece of that, and that could be where we have tornado debris. So right down toward the Alabama line, we have the cool colors, and these cool yellows and blues indicate where there's debris up in the air because of that tornado. So let's go back Let's go back, and you could see the tornadoes down around here, and it sent some debris up in the air, and boom, you can see all that debris down and through here. We call that forewarned debris detector, one of our cool tools from our radar network at News 4. Hey, that's almost all the time we have. I say almost because my daughter is, both my son and daughter love science. And so Sadie, come over here. Hudson, you want to be nearby. They both did this experiment yesterday. We found it online, and it worked very well. And it's to show how you can make a, well, why don't you tell them?
This one is mine.
Yeah? Why don't you guys tell what's going on?
Can it be mine then?
Oh, sure, yeah. What do we do? Do we make a bouncy egg? We made a bouncy egg. Hey, you can do this at home. This right here is just a raw egg. So if I try to bounce this, it's not going to bounce. It's just going to crack and make a mess. But so what we've done is we've actually gotten some regular vinegar. I think it's just white vinegar. And we sat one of these raw eggs in overnight. So follow me to the sink. Follow me to the sink. Oh, I'm not going to break it, and I'm just going to rinse. Vinegar sort of stinks. Well, it doesn't sort of stink. It really stinks. So this is a hard raw egg yesterday. And then I'm going to let Sadie hold it. Yes, Hudson, you can hold one over here and show everybody on the counter here. Here, Hudson, come over here, hon. Show gently. Well, there's one right here. This is bouncy too. How bouncy this is. See how squishy that is? Watch this. See? Bounces. So you can make a bouncy egg at home. And of course, if you drop this really, really high, it's going to look like a big raw egg on the counter. So don't do that. But let's see if we can. I don't know how to get into your phone here. Just trying to turn on a flashlight. What we did discover in this experiment is that eggs actually can sort of glow in the dark. If they're lit up, they reflect the energy and they sort of illuminate the whole thing. So we're trying to get a flashlight where you can see this. And I just realized I forgot one of my experiments. So when we're done, we'll have to go back and get that. But otherwise, we're getting close here to the end. So again, a regular raw egg will break. Ooh, I almost broke it. Were we able to get a flashlight? Yeah. We are efforting that. Oh, here we go. So we'll just flip it up and then just set the egg on it. And look at that. Sweet. Isn't that awesome? So that's just a regular raw egg. Would it work with a hard-boiled egg? Who knows? But you could just, Sadie took this into the bathroom yesterday and it really looked awesome. So something fun to do at home, a science experiment. Hey, last thing I want to do, thank you kids. Last thing I want to do is talk about something I forgot to talk about regarding hurricanes, and that is a storm surge. So storm surge, we've referenced storm surge before, and I think my wife is so mesmerized by the eggs. She was stuck on the eggs. No, please don't break it. We don't want to clean that up. Storm surge is essentially the ocean of the Gulf of Mexico as it rushes inland because of A, the wind, strong wind blowing it that way, and B, lower air pressure above. And so that just makes it possible for the ocean of the Gulf of Mexico. I don't know if you can see my water line here, but this is my Gulf of Mexico, or this is my ocean. And so here's the water. Let's pretend that, dolphins and sharks are in here. And then here's the land. Now, if we had a tropical storm come along or a hurricane come along, it's gonna blow some of that water toward the land. You can see it getting the land. Now, what's really important? What's really important is the slope of the land. Can you see how much this is sloped? When the land has a big slope like that, you get less of a storm surge, but much bigger waves. Now let's take away some of the slope, and let's put it like that. And now we'll get our hurricane going, and watch how the land is just inundated. So the slope of the land goes down, and so the water has a chance to go deeper inland. So if you know like a grandparent or something like that who has property down along the coast and you're worried about like, oh, the next time a hurricane comes, will storm surge, that rise to the level of the water, go deep inland? What's very important is how much the coastline slopes. In Hawaii, it's a very steep slope, so they wouldn't have a big storm surge, but they'd have huge waves. That's why they have such big waves in Hawaii, because of the slope of the land. Okay, any questions? This has probably been our record-long Facebook Live. Any questions? Anybody watching? Anyone there?
I don't see any questions, but people
Good.
are watching. Sherry Judkins said hi.
Hello. Good. Thank you guys so much for watching. Tomorrow is Wednesday, and I believe it's Laura Bannon's time for Facebook Live at 11 o'clock on the main WSV page. Thank you so much for watching us, and I'm on TV outdoors today on News 4 at noon in 30 minutes, so hopefully you can join us then. Have a great day.